across some 15 million square miles of the Pacific, the 1962 Overseas Nuclear Test Series was an undertaking of impressive proportions. The test program, under the code name of Operation DOMINIC, required a technical and operational buildup of unprecedented scope, with planning, preparation, and deployment, all on a tighter time scale than ever before attempted in overseas nuclear test operations. Concurrent testing at 4 widely separated points was necessary to meet these requirements. Off Christmas Island, a series of weapon development airdrop tests was made, followed by later drops in the Johnston Island danger area. All drop aircraft staged from Hawaii. A Polaris weapon system test was launched from the open sea into the northeast corner of the Christmas Island danger area. A combined ASROC anti-submarine weapon system and underwater effects test took place in the open ocean several hundred miles off San Diego. And high-altitude nuclear-tipped missiles were launched from Johnston Island, with instrumentation to gather weapon effects data distributed over wide areas of the Pacific Ocean basin. All were prescribed for completion in the shortest feasible time. Here are the highlights from the high-priority inception of the operation to its successful termination. Operation DOMINIC was triggered by the Soviet resumption of atmospheric nuclear testing in September 1961. The Department of Defense, under presidential direction, on 24 October 1962, activated Joint Task Force 8 under the command of Major General Alfred D. Starbird to prepare for a series of nuclear tests in the Pacific. The job handed General Starbird and his staff was an enormous one. To plan, organize, and prepare the task force and to complete the materiel buildup in time to be ready to fire by the 1st of April, a preparation time only 1/3 of that typical for previous, comparable but less complex test operations. Involved were the organization and movement of over 28,000 men, both military and civilian, along with preparation and shipping of almost 200,000 tons of materiel. Each man and each item was ticketed for a specific point somewhere in the vast Pacific Test Laboratory. This buildup included the development and installation of thousands of pieces of intricate instrumentation. Some were fitted in trailers, some in modified aircraft or ships. Other apparatus was scheduled for direct movement overseas for placement at one or another of the 31 task force overseas sites, which first had to be built, including remote instrument stations carved out of tropical jungle growth. These preparations were all parts of the master plan rapidly taking shape. One group of operations was the weapon development tests. Initially, it was planned that these tests would be accomplished by placing an instrumented ship array in an open ocean area south of Hawaii to control and observe technical data from the detonation of the test devices, which would be dropped by a B-52 based in Hawaii. This airdrop method had a twofold mission. It would provide for the proof test of weapons which, during the moratorium, had gone into the national stockpile without having been tested in weaponized form. And it would provide for the test of new development devices of advanced design. Supplementing the shipboard apparatus were specially modified aircraft diagnostic platforms. While the open ocean preparations were underway, negotiations were being conducted with the British government for the use of jointly owned Christmas Island, 1,200 miles south, as a location for the airdrop tests. In mid-February, the task force was notified that the necessary agreement had been reached. Because of the many technical advantages expected from the use of the island test base, plans were immediately altered to move the weapon development tests there. This location switch was indeed a substantial effort, with the prescribed first shot readiness date only 6 weeks away. The main features of the 1962 test program were by now essentially defined, although many details were far from firm. This fluid condition continued as developments throughout the test period brought forth new requirements. Although work in each of the 4 main areas was proceeding simultaneously, in this film, each of the locations will be considered separately, beginning with Christmas Island. Late in March, the Joint Task Force headquarters began to move to Christmas as the main forward location for the first phase of the operation. This 222 square mile atoll, hard by the equator, was governed by the British. They had used it for their nuclear test operations from 1956 through 1958, but equipment connected with their tests had been withdrawn and their camps deserted. Equatorial weather attrition and the task force's additional needs required extensive preparations for the task force program. Since the atoll possessed no harbor, all ship-transported equipment, materials, and continuing supplies had to be transferred to lighters and barges in the roadstead and moved to the port of London for offloading. Inland, Christmas was dotted with lagoons possessing a swamp life all its own. On firmer ground lived 400 Gilbertese islanders who produced copra from the atoll's thousands of palm trees. The weapon airdrops were made off the southeast shoreline of Christmas Island. The air array was controlled from the Joint Operations Center, housing the command post, the Air Operations Center, and units associated with control of all drop and test elements. Additional radar apparatus located at A site plotted the precise second-by-second position of the drop aircraft during the bomb run to assure that the device would fall within the finite time and space limitations set by scientific and safety requirements. This plot information was relayed directly to the Joint Operations Center by a microwave television link, providing the Air Task Group commander with instantaneous positive information on which to base his operational decisions. Also at A site, as well as at other locations on the island, basic diagnostic instrumentation housed in trailers was positioned to secure data associated with the detonation. Special tracking radars assisted this diagnostic array by assuring they were oriented toward the nuclear device on its trajectory from the instant of release to detonation. Optically and electronically, the trailer diagnostic instrumentation recorded the most minute detail of each detonation in millionth of a second segments for scientific analysis. Under the precise positioning of the Air Operations Center, various types of aircraft also gathered additional diagnostic and weapon effects information. 2 modified C-130s were platforms for fireball measurements with high-speed cameras. They also carried other instrumentation to record data on internal device behavior. This technique, rudimentary at the start, was perfected to a high degree of effectiveness during the Christmas airdrops. Control aircraft backed up the Air Operations Center's positioning of the air array, along with checking out the feasibility of an all-airborne diagnostic concept. Other aircraft recorded thermal radiation, radar attenuation, and chorioretinal effects for eye damage studies. Specially instrumented KC-135 aircraft also recorded a variety of experimental data. Aloft, too, were search and rescue aircraft and photographic planes documenting the DOMINIC detonations. After each shot, B-57 sampler aircraft went aloft, as they had in operations of years past, to fulfill one of the chief diagnostic functions of each event, stalking the radioactive cloud to obtain particulate and gaseous samples for radiochemical analysis. Throughout the DOMINIC tests, maximum security was maintained around the Christmas and Johnston Island test area boundaries by the Navy destroyer and P-2V watchdogs. Round the clock, throughout the entire test period, the P-2V aerial fence riders rose from their Christmas and Johnston bases for their 10 to 12-hour runs in constant touch with the destroyers below. Daily, they greeted the Soviet instrumentation trawlers, which for 7 weeks lurked just beyond the danger zone periphery. On On 23 April, the President directed the waiting task force to proceed with the first shot, a weapon development drop. The initial airdrop was on the 25th of April and the last on 11 July. During this period, a total of 24 weapon development shots were detonated in the Christmas area. All drops were on target and within the precise time and space limitations established by the requirements of diagnostic instrumentation, a record by the B-52 crews, which reflected a high degree of bombardment skill. Detonation technological efficiency also scored high in the fusing and firing systems and in the device telemetry. Throughout the Christmas airdrops, the backup airborne diagnostic method was progressively refined to the point of becoming a proven capability to collect the scientific data required. The weapon development effort was completely successful in all its primary test objectives. The series also yielded important new weapons effects information. Meanwhile, the task force was equally active at its 3 other test areas. Early in May, the test of the Polaris nuclear weapon system was ready for launch by submarine in the open sea. Detonation was scheduled to take place in the Christmas danger area. As the nuclear submarine Ethan Allen moved toward its rendezvous with range, safety, and instrument ships at the launch point some 1,500 miles from Christmas Island, all concerned were well aware that this was not only the first test of the complete Polaris nuclear system, but also the first proof test of this particular warhead in weaponized form. On the 6th of May, the Polaris was fired. Two submarines near the burst area, together with orbiting Christmas-based aircraft, confirmed that the warhead detonated on target at expected yield. The first proof test of a United States ballistic missile nuclear warhead in its full re-entry environment was completely successful. Meanwhile, a group of task force ships several hundred miles off the Southern California coast were completing preparations for the ASROC event. This test had a dual purpose. It provided a system test for the nuclear ASROC anti-submarine weapon system and also a major underwater nuclear effects test using a heavily instrumented test array. 11 May. With test equipment ready, the destroyer Agerholm moved on station. Her regular crew selected an unmodified stock ASROC and lofted its nuclear warhead toward a target centered in the test array. The entire operation was successful, with both the operational and effects test objectives achieved. During this same period, at Johnston Island, the launch center for the high altitude program, deployment of men and instrumentation had proceeded on schedule for a first event early in May. The purpose of the high altitude tests was to gather a wide range of effects data bearing on both the offensive and defensive aspects of nuclear attack upon incoming ballistic missiles, including warhead kill mechanisms and electromagnetic blackout effects on both radar and communications. On mile-long Johnston Island's limited acreage, crowded around and between the runway and ramp areas, were the missile launch complex and a line of more than 30 instrument rocket launchers, together with the many other necessary testing and support facilities. World War II bomb shelters were utilized for housing the command post of the Joint Task Force and other stations manned during the launch events, including those of the Scientific Readiness Team and Launch Control Units. This radar dish, scanning the sky for electromagnetic effects data, is representative of the test equipment set up and operated by the scores of technical projects. The launch vehicle groomed to carry the nuclear warheads to test detonation altitudes was the Thor missile. In the early plans, it was scheduled to do the job for 2 and possibly 3 nighttime bursts at various altitudes above the Earth's atmosphere. For these tests, the Thor was modified to carry 3 scientific instrumentation pods to obtain key data in close proximity to the burst. Each pod was ejected from the launch vehicle at a predetermined position along the missile's trajectory. The Pacific Missile Range ship moored at Johnston tracked the missile in flight for range safety purposes. Other tracking units followed the rocket instrumentation and scientific pods and determined their accurate positions relative to the detonation. Positioned at various distances from Johnston Island were 9 test ships, including the downrange anti-missile measurements program ship American Mariner, on loan from the Atlantic Missile Range. Pod recovery and surveillance ships were also on station, along with an aircraft carrier, whose marine helicopters evacuated from the island all personnel non-essential to the actual operation during each event. But Johnston Island itself was only the hub of an extensive network of land, ship, and aircraft instrument stations radiating in all directions, deep into both northern and southern hemispheres of the Pacific. Between the northern arc of Okinawa, Adak, Fairbanks, and Palo Alto, and the Polynesian islands of Tonga Tapu and Rarotonga, far south of the equator in Johnston Island's southern magnetic conjugate area, the roll call of islands hosting effects instrument stations evokes images both geographical and logistical, especially the latter, for over 200 ground instrument stations were prepared, installed, and manned. High-altitude effects data were also secured from aircraft platforms. More than a dozen planes took to the air from Hickam Air Base in Hawaii for each event, and 3 more from Nandi Airport in the Fiji Islands. Besides the instrumentation ships at Johnston Island, 2 minesweepers put to sea from Pearl Harbor for electromagnetic data recording. And from its mooring at Pago Pago in Samoa, the instrumented motor ship Acania moved out prior to each shot day to be on its mid-ocean station. Johnston's opening event on May the 2nd was a daylight certification shot, testing all systems during flight trajectory, but without nuclear warhead. This proof test went as planned, achieving all programmed objectives. But hereafter, the course of shot events did not follow the scheduled script. The first 2 hot launches did not carry through to nuclear detonation. Neither of the failures was caused by the missile or warhead. On 8 July, the 3rd nuclear launch, another try for the very high-altitude Starfish event, was flawless, including the performance of the many auxiliary instrumentation rockets sent into selected trajectories about the burst region. Starfish detonated at its planned strength and height, producing wide upper atmosphere glow and extensive auroral effects. Here is how it appeared from Mount Haleakala on Hawaii's island of Maui. Recovery of the instrumentation pods ejected from the Starfish missile involved pre-dawn ship, patrol plane, and helicopter convergence in the splash area, drawn by radio signals, flashing lights, and green dye. As soon as the pods were fished from the water, they were taken to the Johnston Island recovery area for removal of the scientific instrumentation. The second bluegill attempt was made on 25 July, but a one-of-a-kind missile misadventure caused by a sticking fuel valve destroyed the Thor and its warhead on the pad. The pad itself suffered extensive damage, including long-life radioactive contamination. Repairs to permit another try at bluegill caused a significant delay. Additional construction on Johnston Island during this interim, as well as the scheduling of more shots, reflected the value attached to the testing being carried out on Operation Dominic. 3 more high-altitude effects missile events were added to secure data at different heights. Also, 5 more over-ocean airdrops were scheduled, these to take place within the Johnston Island danger area. Besides a second Thor launch pad, the construction included facilities for the launch of XM-33 rockets and Nike Hercules missiles. The U.S. Army deployed a missile battery to provide launch support for the Nike Hercules missiles, which were scheduled both as nuclear warhead and instrumentation vehicles. On 15 October, high-altitude testing was resumed, resulting in another failure of a bluegill attempt, this time due to internal missile guidance malfunction. It was the last such disappointment. All remaining launches culminated in detonation at their planned altitudes. First came Checkmate, boosted to altitude by a Sargent-engined XM-33 rocket. Besides furnishing new basic scientific data on upper atmosphere phenomena, the tests fulfilled the vital military aims of providing information on the offensive and defensive aspects of nuclear attack upon incoming ballistic missiles, as well as data on blackout effects on radar and communications. Meanwhile, the 5 additional weapon development airdrop tests in the Johnston Island danger area were conducted. To gain the scientific information required, the airborne array refined at Christmas Island was utilized as the sole diagnostic force, with the original C-130 aircraft joined by KC-135 jets carrying additional diagnostic gear. The makeup of the remainder of the test aircraft formation was generally the same as at Christmas, including the post-shot B-57 diagnostic cloud samplers, this time staging through Johnston Island to conserve flight hours and to reduce pilot radiological dosage accumulations after cloud penetration. The air array was under the guidance of the Air Task Group Commander in one of the RC-121 aircraft, while overall control was maintained by the Joint Task Force Commander from Flag Plot in the Princeton near the drop area. Target rafts were again used as guideposts for orienting the air array as a point of aim for the B-52 device drops. The rafts were moored in the open ocean by the Navy Task Group in water as deep as 3 miles. Late in October, after the last airdrop test device had been detonated, the series was pronounced a success, both in refinement of weapon design concepts developed for the Christmas tests and in further confirmation of the feasibility of the airborne diagnostic method for future testing. With Operation DOMINIC completed and the test apparatus roll-up underway, the time had come to evaluate the far-flung operation and its scientific results. Despite DOMINIC's unprecedented 4-operation complexity, with all the tests prepared under conditions of the greatest urgency in both time and circumstance, the 1962 series is regarded as the most productive since U.S. nuclear testing began. The analysis and correlation of Operation DOMINIC's wealth of test data will continue for some time. Nevertheless, the Atomic Energy Commission and the Department of Defense already have been enriched with vital inputs, both in new areas explored and information gaps plugged. This is reflected in the improvements of weaponry in the national stockpile, in new weapon design, and in the planning for future test programs, should the national interest require them. On all counts, Operation DOMINIC proved to be a significant milestone in the ever-vigilant task of keeping the nation's ramparts secure.